Welcome back to Monroe Tutoring. If it's your first time, then welcome. Let's learn some stuff. So this is part 3 of stoichiometry. If you missed the first 2 parts, check them out. It's going to help in order to understand this. So now let's jump into another problem that is somewhat complex. Let's say we're given a word problem and they're like, in the combustion of ethane, the water is collected and the mass of water produced was 78.3 grams. How many moles of CO2 would be emitted in this reaction? Okay? Now, I already forget the number of grams I just said, 78.2 grams. Let's just say that that's what I said. So we're given grams of one substance, 78.2 grams, and I'm asked about moles of another substance, right? So how many moles of this stuff? And like I said in the first part of this series and the second part, it's always good to write the information underneath the substance in the balanced chemical reaction, okay? It has to be balanced, otherwise we cannot do stoichiometry. So we're given grams of something and we want to know about moles of something else. Now, I'm going to just write something slightly out of order this time compared to how I did it last time. I'm going to just start off with the ratio of these two compounds. So as I said, in stoichiometry, these coefficients are the ratios between the moles of basically any compounds in the reaction. You could also say it's the ratio between the molecules, but in this case, we're talking about moles, so let's just stick with that. So we're given info about water, so I'm going to write over here what the ratio is. It's 6 moles of water for every, and I'm being asked about CO2, so I'm going to write this, 4 moles of CO2. 4 moles of CO2. Okay, now with that written down, let's start the problem how we do every time, which is we take the given information and we put it to the left and we label everything properly. So we're going to start with 78.2 grams of water, and we're going to put a parenthesis here. Now, in the other problems, when we do stoichiometry, we're given some information about a substance, and so far we've immediately used the mole ratio. But now we look here. We know that this is the ratio to, this is how we go from moles of one substance to moles of the other one. But I don't have moles of water here. I have grams of water. So I can't use this yet. Because if I tried to, if I put 4 moles of CO2 and 6 moles of water and grams of water do not cancel. So in other words, we're not ready for this yet. We know we're going to have to use it at some point because we're trying to go from information of one compound to information about another compound. This will come into play, but these units don't cancel, so we're not ready. Now, we're going to be canceling out moles of water eventually, right? So we have grams of water. We need to get to cancel out moles of water. What thing relates mass and moles? Mass and moles, moles and mass, that's the molar mass. So we need the molar mass of water in order to proceed in this problem. So let's quickly do that. Again, I have a video on how to calculate the molar mass, so I'm going to do it really quickly right now. We don't use the coefficient here. We're just looking for the mass of a mole of water, a single mole, right? So there's 2 hydrogens, so that's going to be 2 times the molar mass of hydrogen, which is 1.008 grams per mole. And there's only 1 oxygen, and that's 16.00. And so we get, that's 16, 17, 18. Let's write this over here. 18.016 grams per mole. And now, again, I like to write the molar mass out as a conversion factor, because this way it makes it a bit more straightforward in order to plug into our parentheses and just do all our math via dimensional analysis. So I'm going to write that out over here. There's, for every 1 mole of water, that's equal to 18.016 grams. And again, let's label everything really well. So now I have grams of water. I have a conversion factor that has grams of water in it. I'm good to go. I can cancel those units and keep this moving. So 18.016 grams of water is going to go down here. 18.016 grams of H2O. The other side of the equal sign has to go on the top. That's 1 mole of water. And so grams of water and grams of water cancel out. If I stop the problem now and I just did this math, I would have moles of water. But we're not being asked about that. We're being asked for moles of CO2. So I set up another parenthesis, and then what piece of information relates moles of water to moles of CO2? That's the coefficients from the balanced equation. And this part is what makes it stoichiometry, right? So let's plug this stuff in. We want to cancel moles of water, so we're going to do 6 moles of water, 6 moles of H2O for every 4 moles of CO2. 4 moles of CO2. Let's close that off, and let's do this math. So I have 78.2 grams of water. I'm going to divide that by the 18. I always skip the 1, so I'm going to just hit divide by 18.016. And then I'm going to multiply, you can reduce this if you want, but it doesn't make a difference, right? So multiply by 4/6, just to keep things simple. And I get 2.8937. How many sig figs should I have? That's 3. That's 4. Well, that's actually 5. So 3 is the lower amount. If you don't know sig figs, check out my 2 videos on sig figs. So we're going to do 3 sig figs. We're going to do 2.89 moles of CO2. I forgot to cancel out these units. Those are gone. And so we know that we have moles of CO2 as our final answer. All right, guys? So again, when we want to go from moles of one compound to the moles of the other compound, we use the coefficients and we write out our conversion factor. But if we're not given moles, if we're given grams, we have to get this into moles first, and we go from moles to mass or vice versa. It's the molar mass. All right, guys, if this video helped, please give a like, follow, share, save this to review later. And if you'd like to go above and beyond, check out my links, and you can patronize me over there to keep making these videos for free. So thanks for the support, and I'll see you guys in the next one.